I want you to finish this phrase in your head. All that glitters is not. You likely arrived at the word gold instantly. Your brain predicted the next word in the sequence before you were conscious of the effort. The same automatic response occurs when you hear the famous historical quote, et tu, your mind fills in, Brutus, the next term in a sequence. While humans read a sentence to find an emotional or philosophical point, a computer has no such capacity. An LLM is a machine that processes pure mathematics. This creates a massive technical hurdle. How do you take a machine that only reads numbers and force it to fluently speak human language? The process relies on translating our vocabulary into a rigid geometric map. To build this map, every single word must first be dissected and cataloged. Before the AI can predict anything, it must first destroy the sentence structure humans are familiar with. This step is tokenization, breaking language into modular segments. By separating a suffix like ing, the machine creates a mathematical indicator. That segment tells the system an action is occurring, whether attached to eat, dance, or sing. This creates an efficiency advantage. By learning the mathematical rule of the ing token once, the machine understands the context of thousands of verbs without needing to encounter every individual variation. Spaces and punctuation marks are also converted into individual tokens, ensuring the machine accounts for every nuance of a sentence. Tokenization is the critical bridge. It converts messy, organic speech into standardized data blocks that a computer's processors can finally calculate. But after the language is segmented, the AI faces a new challenge. It has to determine what those individual pieces actually mean in relation to one another. The AI has no concept of what fruit tastes like, but its coordinate proves it is identical in category to a banana. This process has been applied to the entire English vocabulary, plotting every known term into these interconnected spatial coordinates. To a machine, the abstract concept of meaning is a measurable geometric distance. We can now see exactly what happens behind the screen the moment you hit send on a prompt. The large language model receives your input, instantly segments it into tokens, and plots every single piece onto its vast vector map. Once the pieces are placed, the LLM acts as a navigator. It looks at the current coordinates of your text and mathematically calculates which neighborhood on the map it needs to visit next to finish the sentence. It is easy to assume these systems are thinking as we do, but they have no brain and no genuine understanding of our world. This intelligence is the result of standardized language segments being navigated across a massive mathematical map.